that we don't fill out the learning intention. Like starting in chapter 2 when I rewrote all the worksheets, I don't care if we know the learning intention or not. If you want to know what the learning intention is, I post it on Canvas. It's just what all the vocab words are on that day, right? So today is like parallel, perpendicular, skew, linear pair, vertical angles, right? I don't want us to write all that down. So if I asked you what parallel meant, what do you think? Do you have a rough idea of what it meant for lines to be parallel? What do you think? I like the fact that somebody said opposite reciprocals in algebra. That's if they have. Here's what it means to be parallel in math. They have to be in the same plane. Coplanar lines that do not intersect. Coplanar lines that do not intersect are called parallel. Coplanar, they got to be in the same plane. But in English, that means they go in the same direction. Like I know in video land you can't see the rulers that I'm holding up right here, but these two are totally, they're like railroad tracks. They go in the same direction. And real quick, why are these not parallel? Because they intersect. They touch each other, right? Are you with me on that? So they got to never touch and be going the same direction in English. Could you please like draw these two lines in a little, I know I didn't give you much room. Starting in chapter 2 you'll have more room, but notice I called one of them line A and I called one of them line B. Just with a lowercase letter. It's supposed to be cursive. I don't care if you can't make the cursive letter, just make it lowercase, right? So a lowercase a and a lowercase b. But we're getting pretty picky about some of these markings. They say, how do you show lines are parallel in a picture? It doesn't matter what they look like. You know, they could look parallel all day long. It's if they're marked with these arrows. So put like an arrowhead maybe in the middle of that guy and an arrowhead maybe in the middle of that guy. Those arrows mean that the lines are parallel to each other in a picture. So we're going to put arrows right here. They're different than the arrowheads that mean that the guy goes on forever and ever and ever. Right? Those are different, but they're in the middle of the picture. And you could also have like double arrows, but double arrows and single arrows aren't parallel to each other. They have to be like double arrow and double arrow. For example, I'll show you in chapter 6, we'll draw like a parallelogram. Like these sides are parallel to each other, and those sides are parallel to each other, but they're not all four parallel to each other. You have two different sets of parallel guys, right? So it's about the arrows on there. But that's in a picture. In a math statement, here's what I'm going to do. I'm going to say something in English, and we're going to write it in math. Line A is parallel to line B, right? Didn't I totally say that in English? Here's how we'll write it in math. This is how you write This is how you write line A. Just a lower, you can write with me, like a lowercase cursive a. And here's the symbol for is parallel to. It looks like two slashes just right next to each other. You've probably seen that before, but just refreshing your memory. Then line B after that. That totally says line A is parallel to line B. In a math statement, it's two slashes. In a picture, it's the arrows. You might see some really weird typed instructions that have them straight up and down. I hate when they're straight up and down like that. I like them slashed instead, but it still means parallel. You're cool with how to tell if things are parallel in the picture or with symbols. Then I've known that people kind of know what perpendicular means, but we get it messed up. If things were perpendicular, one, should they intersect? What do you think? They totally will. But they intersect at a special angle. Like these are not perpendicular. It would be more like this. What kind of angle do they have to intersect at? 90 degrees or a right angle, right? So that's what perpendicular means, is lines, rays, or segments that intersect at 90 degrees. Lines, rays, or segments that intersect at 90 degrees. Lines, rays, or segments that intersect at 90 degrees. And then when you get that written down, if you go off either in that little space or in the margin, sketch those two pictures that I have right here. I've got a little X and a little Y, and a little A and a little B. And when we do homework, we'll always use a straight edge to make these pictures. But since I didn't give you much space on this, if you just want to sketch them, that's fine. Yep. Line X, line Y, line A, line B. Lines, rays, or segments that intersect at 90 degrees. And we've kind of talked about it before. The bad part is in this first chapter, whoever typed these worksheets make us assume a lot of stuff is perpendicular. But they're supposed to put something in the picture for you to know they're perpendicular. Have you ever seen this little guy, boom, that little box right there? You know, some people call it the square. We call it the box, right? So in a picture, that right angle box means that those intersect at 90 degrees. But a lot of people misinterpret. They think that one has to be horizontal and the other one has to be vertical. You know, it always has to be that way. It's like, no, dude, that could be at any angle you want. That's why I drew this second picture right here. Those dudes right there could totally intersect at 90 degrees. So that's in a picture with the box. Then I'll say this in English, and we'll actually say it together in English because it's weird, right, you know. But I'm going to say line A is perpendicular to line B. So here's line A. And maybe you've seen this symbol before, but I'm going to wager probably not. The perpendicular symbol looks like this. How do you feel about that looking like an upside down capital T? Right, you know, that's the perpendicular symbol. Line A is perpendicular to line B. And because I know how weird this class can be if you don't know how to read it, we're going to say this once. I'll say it, you say it. Line A is perpendicular to line B. Thank you very much for doing that. Could you do this for me? Somewhere near this picture, could you take my English sentence that I'm about to say and write it in math? Line X is perpendicular to line Y. Could you write that in math? Line X is perpendicular to line Y. And I'm going to do that over here. But it should look like this. A lowercase x, upside down capital T, and a lowercase y. Again, they're supposed to be cursive. I'm cool that they're lowercase. Is that all right with you? So, the upside down capital T means perpendicular. That's a big word. Then skew is what we were talking about earlier. Let me kind of go back before we do it. That would be these lines. First of all, are these two guys right here parallel? Yes or no? Nope, they intersect. Are these parallel? Yes. Are these parallel? No. And do you know why in English? It's because they're not going the same direction. They are totally not. One's going left and right. The other one's kind of going up and down. That's what skew means. But in math, it's like this. Non-coplanar lines. That means they're not in the same plane. Non-coplanar lines that don't intersect. Non-coplanar lines that don't intersect. And then maybe in English we put, if we got room, they don't touch. They totally don't touch and go different directions. They don't touch and they go different directions. And we'll clean that up a little bit later of how to find skew lines. But they ask us to take a picture of basically a cube right there. What's missing is a right angle box. This is a bad picture, so could we please put a right angle box like in the lower corner? Sorry it's so low on your screen, but I got to leave it this way. But here's what we're going to learn. That finding stuff that's parallel, like question 1 here, finding stuff that's perpendicular isn't nearly that hard to do. But finding stuff that's skew is a challenge. So I'm going to make like a small rule. Whenever they ask us to find stuff that's skew, we're going to use highlighters, and I'll show you how to do that when we get there. But for these other guys, I don't want to use highlighters, but you can definitely darken with a pencil. I'm going to use highlighters so you can see what I'm talking about because I'm the teacher, but I don't think you should use a highlighter due to the fact that you can't erase them on your paper. Cool? So check it out. What do you think about this guy right here and this guy right here? Are those parallel to each other? They're in the same plane, right? You know, the planes are the faces, and they don't touch. So I'm going to write these down. You don't, because I want you to pick a different one. This is line PW and line QX. Do you see how I put the line bars above? If I could put an X, that'd be awesome. Do you see how I put the line bars above them because they asked me to list lines? Could you and your table mate find a different set than mine that you think are parallel? You don't have to highlight them, just maybe darken them, and then I'll call on a bunch of people. In class, we picked on a bunch of parallel. Now let's try one that Mr. Fonestil asks. You tell me. I'm going to highlight a couple here, and you tell me, should these be parallel? Remember my line QX? And what about line SZ? Discuss with your table mate, are those parallel or not? The answer is that those are parallel. And here's the weird part. They're supposed to be in the same plane. Small visual aid here. Does this thing have length? Does it have width? And can you pretend it has no height? This is like a plane. And we've got this cube right here, which I know this is small and hard to see, but it's like I totally could put this plane in it. That's like the upper left-hand corner of this cube and the lower right-hand corner of that cube, and I can draw a plane in between it, which is hard to see. Here's the main thing. Do they touch? Are they go in the same direction? What do you think? Those are parallel to each other. Sound cool? Can you find a set that are perpendicular, aka they intersect at 90 degrees? Thank you. Find it, write them down. Danger of skew, right? So like, let me erase this, and let's try some skew. Talk to me. I'm just going to try because I can erase my highlighters. What do you feel about this dude right here and this dude right here? Do they touch? Nope. Are they going the same direction or different directions? Those are skew. Are we cool with that? Those are skew. So I'll call that like line QX and line PS. And I forgot to write down some perpendiculars. For an example, line PS and line SR were perpendicular. But this question is too easy because it's a cube, right? I want to get to a harder one and show you how to highlight to find skew. And last hour they did awesome with it, so I bet we'll do just as well. Check it out here. I do not suggest that you highlight number 4 because parallel is pretty easy to find. But what I think would benefit you is darkening it with your pencil. Can you darken segment QR with your pencil just so you can see him? I'm going to highlight just because I'm the teacher, but darken segment QR. And here's what we're looking for. Can you find some guys that don't touch it and go the same direction as it? Shout them out. Who's? Okay, I heard an XA. I'm going to use a different color. Just talk to me. What do you think? Is segment XA good? Okay, so let's write him down. Segment XA is one. There are others, right? You know. Who's another one? Say that one more time. OG. Is that what somebody said? Okay, let's try it. Does segment OG touch the pink one? No, it does not. Is it going the same direction as the pink one? Not quite. It's like the pink one's going like this and the other one's going like that. So I like it. We tried. You know, we're looking for parallel, right? We're looking for parallel, right? So who's another one that go in the same direction and touches that one? Or, excuse me, doesn't touch it. I heard segment HO. Let's make sure we say segment. Segment OH, segment HO, however you want to call it. There's one more. Segment MT. Now, the highlighters, I think, help a lot, but you will see that the skew stuff is very hard to see. So with parallel, maybe you just darken them with a pencil because you can't erase your highlighters. Unless you had a bunch of different colors, you'll still end up seeing that it's complicated if you highlight all this stuff one color and then you got to switch a whole new question. So that's all of those. I'm going to erase, and now I'm going to force you to highlight because they're asking us to find skew. Phase 1, pick a color, highlight the segment they are talking about. Segment AG. And here's my advice. To find guys that are skew, I've been doing this a long time. We've learned to backdoor this. The easiest way, I think, to find guys that are skew to this is to find dudes who are not skew to it and highlight them. So grab a second color. And just to bring back these guys again, remember, these are not skew. Why not? Because they are, starts with a P, they are parallel. So how about we go find everybody that's parallel to this and highlight them. So I'll start you off. I'll use a different color. So remember, AG is in one color. Here's RS. Do you see how he's parallel to him? He can't be skew to it because it's parallel to it. Find some more. Who are the guys that are parallel to this guy? Who you got? SR. Got him already. HE, like him. Anybody else parallel to him? Segment MN. Is there anybody else that's parallel to him? So what I'm doing is saying these pink guys cannot be in my answer because I want skew, and these are parallel to it. So these were not skew. What about this? Why are these not skew? Because they intersect is the word. They do touch. I'm looking for the word intersect. So how about we go find anybody that intersects this guy? Like, what do you think about this? Sorry. What do you think about this? Does that intersect the green one? He touched him, right? So find them all. Who intersects that dude? The ones that touch the green guy. What do you think? Segment. Can't hear, sorry. Especially, I think the air conditioner. XA touches it. Can't be that guy. Segment RA touches it. Anybody else touch it? Segment OG touches it. Is there anybody else that I haven't highlighted pink that touches that green guy? Go ahead. Segment XQ. I'm going to highlight him in orange color just to see what's going on. Did he touch the green one? Nope. Is he going the same direction as the green one? Nope. So we're going to hold off on that. I like the suggestion, though. Is there anybody else that touches the green one? That's almost it, right? You are correct to say that nobody else touches it, but here we got to add one little thing to the rule, because back here this was too easy. It was a cube, right? Everything's squares, right? Do you notice that this guy does not have a square for a base? It has a six-sided polygon that we will soon learn is called a hexagon in that, right? So check it out. I know it's kind of hard to see, but here's that segment AG right here. This guy is that segment AG. We have got this dude that touches him, this dude that's touching him. One major rule is they can't be in the same plane as it either. So do you see this yellow face right here? That is a plane. I need to get rid of, I'm going to use a different color. You can use the same color as before. I need to get rid of this one and this one as well. Are those two orange ones that I just highlighted in that face of that green one, right? So it's like three rules. If we go back here, they can't touch, they got to go different directions, and can't be in the same face. They can't touch, they got to go different directions, and can't be in the same face. And that will only really happen to you when you don't have like squares or rectangles, when you have like pentagons or hexagons. So they can't touch, they got to go different directions, and they can't be in the same face. So everything that I have highlighted is not skew. Guess what that means? Our answer is everything that we didn't highlight, right? Everything that we didn't highlight. So I'm going to start writing them down. Segment MH. And then what I'm going to do is just mark it that I've used it, right? Segment MH, used him up. Segment NE, used it. Keep going. Everything that hasn't been highlighted is the answer to this question. I like to tick them off like that. I have wrote them down already. And there's a bunch of them, man. So segment QX, come on, man. Boom, used him. Segment QR. No particular order I'm going in. I'm just finding all of them that I didn't highlight and writing them down. TO. Segment MT. Segment NQ. I think I got them all. I may have missed some. It's a hard to see problem because it's a three-dimensional object drawn on a piece of paper, which is not an easy thing for people to see. But if I went back and used a fourth color here, can you see this guy? He doesn't touch the green one, he's going a different direction, right? He doesn't touch the green one, he's going a different direction. Even this one, even though he doesn't touch the green one, since he's in the same face, the green one and the blue one would intersect eventually down the road if they were lines. So that's skew, baby, which is a weird, weird, weird one. Cool. 2 words left, and they are huge. We will use these next 2 concepts all year long. Starting in Chapter 2, we're going to start doing proofs, and we need these next 2. So if you would, put a big fat asterisk right here saying these next 2 things of linear pairs and vertical angles are important. Please, 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 if you struggle with these today, let us help you. If you struggle with them by the end of the week, we need to help you. Let's see if you can break it down. I can see in our faces we are tired, right? So let's break it down. Pair. Does that mean how many things are in a pair? More people, please. How many things are in a pair? Two. Root word of linear. Take a wild guess what the root word of linear is. They are line. This is, in English, is like two angles that make a line. But they have to touch each other. But here's the official definition. Two adjacent, we got to spell that right also, so I'll spell it for you. Two adjacent, A-D-J, A-C-E-N-T. Two adjacent, timeout, what does that mean? Touch or no touch? They got to touch. So supplementary, two adjacent supplementary, help me with that, adds up to 180. Two adjacent supplementary angles. And like I said, this is a big deal, but they're not that complicated. To draw an example, I have a cheat code. We're going to cheat. It's linear. Here's how we're going to start. We're going to draw a what first? Use your straight edge, please. Let's draw ourselves a line. Please use a straight edge for these. You'll thank me later. I'm going to draw us a line. Then take your straight edge and branch off of that line any which way you want. Maybe make yours similar to mine so it looks like this. But I'm going to go like that. And we'll call this angle 1. And we'll call that angle 2. And I want to take a time out once we get it drawn and just really break it down. You don't have to highlight this. I just want to show you. How do you feel about I have an orange angle and I have a pink angle? Do they touch? Do they form a line? That's called a linear pair. It's got to be two, though, right? It's got to be two. Now, let's figure something out because we are smarter than we think, guys. You know, let's make up 50 degrees for that bad boy right there. Put that on the inside. I didn't measure it. I'm just making it up. But remember, these are supposed to be supplementary. They add up to 180. If this one's 50, you can figure out who that guy is. If you need to use a calculator, great, you know, but how much does that one got to measure? I didn't hear you, I'm sorry. 130 degrees. Those are supplementary angles. You just proved a theorem, guys. It's called the linear pair theorem, that if you have one of them being 50, could you figure out the other one being 130? Because aren't they supposed to add up to be 180 degrees, right? So I'm going to change the numbers here real quick. You don't need to draw this, but if I had this being 160 degrees, could you figure out what that one's got to be right there? How much? Not quite 40, but 20. They don't add to 200, they add to 180. Please use a calculator. Rock on. Bonus question. Don't need to draw it. Is this angle right here and this angle right here, discuss with your neighbor, a linear pair? Those two green angles, are those a linear pair? Do they add to 180? Are they a linear pair? Why not? The answer is no. They're not adjacent, right? They have to touch each other in that case. Next question. Don't draw it. This is a homework question. Are those a linear pair? Discuss with your neighbor. Are those a linear pair? What do you think? Yes or no? Linear pair. Answer is no. Why not? There's three. There's supposed to be two. But I know you're getting tired. Hang with me. Here's the best advice I can give you on 3 homework questions. I'm going to highlight something. What did I highlight? Starts with an L. A line. Do you remember how much all the angles, regardless if it's a pair or 3 or 5 or 7, what they always add up to be degrees-wise? How much do they always add up to be? 180. Grab a calculator. If this one's 40 and this one's 85, find the measure of that. What do you get? Well, I got 55 or 65. I need a little help. 180 minus 85. How much? 55 degrees. Did you see I also put it in the picture? I did a bad job last hour and didn't tell them to put stuff in the picture. You will be a lost little puppy on homework and your test if you don't put info in the picture. So if you figure something out, put them in the picture. Cool? Bonus question. Orange ray, green ray. It's not green. How about now? Green ray. Discuss with table group. Are the orange ray and the green ray perpendicular? You can look up what perpendicular means. It's up right above you on your paper. The orange ray and the green ray, perpendicular? What does perpendicular mean? Intersect at? These intersect at 85 degrees. Are they perpendicular? Close, but no cigar, right? Looks like it, doesn't matter. Actually measures 85. Cool? And then lastly, bonus questions. Please check this out. Do I have a blue line and a red line? And they intersect at what I'm calling an X. Are you with me on how they make an X? Awesome. Help me out with something. Let me get this. I'm going to draw this. I got to rotate it a little bit. Sorry, that slipped. Holy cow. Let me redo that. Sorry. Okay. Grab, rotate. I'm going to cover that up and discuss this question. Are angles 1 and angles 2 a linear pair? Highlight this. There's angle 1. There's angle 2. Do they touch each other? Do they form a line? Are they a linear pair? Yes. Can you figure out what angle 2 measures? What do you think? 80 degrees is correct. That's called the linear pair theorem. Time. I'm going to move this. Can you find another angle that is a linear pair with angle 1 in this picture? Pick on angle 1. Who's the linear pair to angle 1 besides 2? If I rotate this around a little bit, cover that up, rotate it a little bit better, is angle 1 and angle 4 a linear pair? How much should angle 4 measure? 80 degrees. And then finally, are angles 3 and 4 a linear pair? Yes or no? Are angles 2 and 3 a linear pair? Yes or no? Regardless of which way you're looking at it, how much should angle 3 measure? Yeah? Would you do me a favor in the margin, draw that picture, just like I got it. It's just got to be small. Make 2 lines that cross each other in an X. Draw that picture. I totally set you up. I want you and your table to discuss, do you see something special about these 2 in the orange boxes and these 2 in the blue circles? What do you notice? Orange boxes, blue circles. What do you notice? Something's cool with the orange boxes, something's cool with the blue circles. Orange boxes, what do you notice? A lot of things. What do you notice? They're the same. Are we cool with the orange boxes are the same? What do you notice about the blue circles? They're the same. Are those linear pairs? No. Would you agree you need an orange box and a blue circle to add up to 180? Are you with me on that? But orange box and orange box are the same. Blue circle and blue circle are the same. Those are called, this is a bad name, they're called vertical angles. And I'm going to explain more in a second. Are these right across from each other in the X? And these right across from each other in the X as well? That's what vertical angles are. 2 angles who are across from each other in an X. 2 angles that are across from each other in an X. This is totally not the real definition. I made that up myself because the real definition is too hard to understand. But in our own words, 2 angles that are across from each other in an X. I don't even know what the real definition is. I have to look it up. I've been doing this for 20 years and I don't even remember it myself. Thanks for asking. But I don't know. It's weird, you know. It's hard to understand, you know. This one's easy to understand. 2 angles across from each other in an X. Just freehand this because you don't have much space, and leave a little space down below because I'm going to add to this. So draw you one line going this way. You can freehand it, and real skinny like. Another one going that way. Similar to what we just drew a minute ago, but my question is, do you understand what I mean by an X? You know, like they intersect at an X. Are those perpendicular? Perpendicular means they intersect at what angle? 90 degrees. Are they perpendicular? Nope. Put an angle 1 right here, an angle 2 right here, an angle 3 right here, and an angle 4 right here. And we're still new at this. You don't have to highlight, but you see how I picked on angle 1 right here? Who's across the X from him? Discuss with your table. Is it angle 2, angle 3, or angle 4? Who is across the X from him? Which one? Angle 3. Let's put 20 degrees inside of that bad boy. And let's use what we did a second ago back here. What did you notice about the guys across from each other? How much do they measure? Not 100 and 100, not 80 and 80, but they measure the same. So if this one's 20 degrees, how much is this one got to be right here? 20 degrees. Are you cool with that? Vertical angles, put an arrow down here, they always measure the same. They measure the same. That's called the vertical angle theorem, which we will use a lot this year, but we'll get used to that next chapter. My important part right now is, do you know what vertical angles are by the end of this chapter, and know that they measure the same amount? Could you figure out angle 2, though? Like, aren't 1 and 2 a linear pair? Are you with me on that? If this one's 20 degrees, how much does angle 2 have to measure? 160. Are we cool with that? Then what's angle 4 got to measure? 160 degrees. Are we cool with that? But let me fix some stuff that I forgot to explain last hour. You don't need to draw any of this. I'm just going to ask you some questions. Let me get some arrows on this bad boy. I do have a couple more before we do homework. I'm using different colors for a reason. Nope, don't need to draw this one. 1 and 2. Are those vertical angles? Yes or no? Discuss. You are new at this. It's totally cool if you're not sure. What do you think? 1 and 2, are those vertical angles? Let me also correct the fact that a lot of people are like, aren't they horizontal? You know, it's like, remember, like, vertical means up and down, and horizontal means this. You're totally right. Those are going horizontally. That's why I said this is a bad name for these angles. It doesn't matter if they're going horizontal, vertical, or oblique. Are they across from each other in the X? What do you think? Yes. Those are vertical angles. So, boom, boom, right? Like I said, you don't have to draw. Hey, question here. Angle 3 and angle 4. Are those vertical angles? Kinda, but not really. Is the red thing a line or a ray? It's a ray. So my advice, when the pictures get complicated, I got 2 more here that I want to show you, is highlight some lines. You know, like, you know, that's a line, and that's a line. And if you make some lines across the way from each other, those are totally vertical angles. So I thought I had more. Let's go to the homework and check out number 1. It's on the back side. And the instructions are bad. Don't forget that I had really bad, like, worksheets here. Here's what I want you to do. You don't have to write this down in the instructions, but on 1, it's got like parts A, B, C, D. Is that correct? Here's what I'm looking for in the answer. You will answer either vertical angles, linear pair, parallel, perpendicular, or intersecting. They're asking you, what's the relationship between these? They might be linear pair, they might be vertical angles, they might be parallel, they might be intersecting. So let's do 1A together. Can you highlight those, bless you, can you highlight the angles that they are talking about? Bless you. Not everybody needs to highlight, but man, does it make a difference in seeing some stuff. So we'll do 1A together. Angle ABD from A to B to D. How do you feel about me like highlighting ABD? Pick a different color. Can you find angle HBC? And it kind of keeps, you got to keep going with that ray. But here's what we're talking about. Are these angles or are these lines? These things that I just highlighted. What are these? I'm going to point to something. I'm not trying to be Captain Obvious here. What did I just highlight? Lines or angles? But it's new, right? You know, it's like, well, it's like kind of a line. It's like a ray, but the two rays make an angle. Are you with me on that? So if I give you multiple choice, vertical angles, linear, pair, parallel, perpendicular, intersecting, would you believe only two of those are types of angles? Vertical angles or linear pair? Discuss with your neighbor. What do you think those two guys are right there? You got a 50-50 shot. Are those linear pair or are those vertical angles? Thoughts? What are they? That's the answer to the question. Please spell vertical correctly. It's vertical, C-A-L, not C-L-E. Vertical, like it's your pal. Vertical, not vertical. It's not a C-L-E. It's not a popsicle. It's a vertical, like it's your pal. You can abbreviate angles with the angle signal and apostrophe S. Try B. What are angles 1 and 4? Discuss. Are they linear pair or vertical angles? What do you think? Linear pair or vertical angles? Those are a linear pair. If you just write the word linear, that is not good enough. You must have the word pair after it also. Linear pair. I'll do part C and turn you loose. What does this say right here? Line AC and line T. I don't care if you highlight or don't highlight. I'm going to show you. Here's line AC in orange. Here's line T in orange. How do you feel about there's no way those could be vertical angles and they can't be a linear pair because they're lines, not angles, right? So either parallel, perpendicular, or intersecting. Discuss what you think. How would you know if they're parallel, perpendicular, or intersecting? Parallel have arrows on them. Perpendicular is marked with the box. And intersecting doesn't have any of those. What is your answer to this? Line AC and line T are parallel. Continue. Please, we have plenty of time. I want you to get this whole assignment done in class. I want to check it as we go along. If you have a question, I'd be happy to help you. But let's work together. Answers are up here if you'd like to check. And let's get her done.